Okay. Good morning, students. In the last class, we have started the last unit, that is tuned amplifiers. Just we will verify very speedily what we have discussed. Okay. Tuned circuit. What is tuned circuit? RLC, which is called as a tank circuit. We call this as a tuned circuit. Okay, the tuned circuit is capable of amplifying signals over narrow band of frequency, which are center frequency FR. Okay, the amplifiers which amplify such the center frequency with side bands are known as tuned amplifiers or narrow band amplifier. Okay, here we can observe the center frequency and side bands will vary within the range of 5 to 10 kilohertz. 5 to 10 kilohertz. Class లో అంటారు. క్లాస్ లో అన్న తర్వాత చేస్తాను. The center frequency generally vary from 1 to megahertz. Whatever the frequency we are indicated here, FR will range with a 20 megahertz, 30 megahertz, 40 megahertz, or 1 megahertz, 2 megahertz, like this. Okay, the center frequency point. But when we verify the lower cutoff frequency and higher cutoff frequency, it is varying within plus or minus 10 kilohertz from the center frequency. And the center frequency అటువైపు ఒక -10 kilohertz, ఇటువైపు ఒక -10 kilohertz. That is the bandwidth is generally varying up to plus or minus 10 kilohertz only. That is these narrow band frequencies. Narrow band frequency and the frequency is the center frequency is at very high and bandwidth is very low. Okay, such type of amplifications are required for certain applications. Okay, those circuits will be designed with respect to these tuned circuits. The tuned circuits are simply called as tank circuits. Okay, we have verified the relation of the resonant frequency FR equals to 1 by 2 pi root LC, and similarly the resonance impedance equals to L by CR. Okay, the condition for resonance and the impedance of resonance. And what is the resonance? Resonance equals to the when the frequency of the applied circuit is equal to the natural frequency of the tuned circuit, then the circuit is said to be under resonance. Under resonance, the circuit is purely resistive. Circuit మనకి ఎలా ఉంటుందంటే purely resistive లాగా కనిపిస్తుంది. అంటే the reactive components will nullify. The reactive components due to capacitance and inductance will be nullified. Only the impedance that is we are seeing is purely resistive. In the last class, we have verified about the losses. There are 3 types of losses, that is with respect to the inductor, that is copper loss, eddy current loss, and hysteresis loss. Okay, and we have defined the parameter called as quality factor. Quality factor is indicating how much the inductor is pure. It is a measure of how pure the real pure or real an inductor. Simply, we can define the relation as quality factor can also be defined as measure of efficiency with which the energy can be stored. Okay, inductor is enta efficient energy store chestundo, that is indicated with respect to the quality factor. Generally, quality factor should be very high. Then the reactive component of the inductance will be very high. It is given by the relation quality factor Q equals to 2 by times maximum energy per cycle divided by energy dissipated per cycle in the tank circuit. Okay, there are 2 types. That is quality factor can be measured, that is in the series form and parallel form. The series form lo unnappudu manaki quality factor relation is omega ls by rs, whereas in parallel form the quality factor is given as rp by omega l. Okay, these are the 2 relations when the tank circuit is in series. Sorry, when the inductor is in series with resistor, when the inductor is in parallel with resistor. Okay, you have to remember. And similarly, the quality factor can be defined in 2 more relations, that is unloaded quality factor and loaded quality factor. The same relation, unloaded and that is one relation to U is indicating unloaded without having any load. then the relation is same as the above, that is 2 pi into maximum energy stored per cycle, energy dissipated per cycle in the tank circuit. Whereas for loaded circuit, the denominator will add one more component, that is energy dissipated per cycle due to the presence of external load. And external load add చేయడం ద్వారా what is the effect of quality factor. Okay, and similarly the quality relation between the quality factor and bandwidth equals to FR by Q, or Q equals to FR by bandwidth, that is F2 minus F. Okay, here we can see when the quality factor is large, bandwidth is small, then the selectivity is high. Similarly, when the quality factor is small, bandwidth is large, and selectivity is low. Okay, in general, high bandwidth small గా ఉండాలి, క్వాలిటీ ఫ్యాక్టర్ అనేది ఎక్కువగా ఉండాలి. అంటే నాకు ట్యూన్ యాంప్లిఫైర్స్ అన్నింటిలో కూడా బ్యాండ్విడ్త్ చాలా తక్కువగా ఉంటుంది, క్వాలిటీ ఫ్యాక్టర్ క్యూ ఫ్యాక్టర్ విల్ బి వెరీ హై, అండ్ ద సెలెక్టివిటీ అంటే ద సెలక్షన్ ఆఫ్ సెంటర్ ఫ్రీక్వెన్సీ ఈజ్ వెరీ హై. ఓకే, వేరే నార్మల్ యాంప్లిఫైర్స్ మనం చూసుకున్నప్పుడు బ్యాండ్విడ్త్ ఎక్కువ ఉంటుంది. The circuit is designed with a tuned circuit there for the lower frequencies, then quality factor is very small. Okay, similarly the other relations for the quality factor, Q equals to XL by R, omega RL. Omega R is angular resonant frequency, L divided by R, where omega R can be written as 2 pi FR into L by R. Okay, the advantages is high selectivity, smaller collector supply voltage, small power gain. And the reason why we are these tuned circuits are not used for low frequency, because of the size parameters of the inductors. Inductor size parameter చూసుకున్నప్పుడు it is very big size and it's a bulky and cost. And similarly for low frequency of operation 20 Hz to 20 kHz, this cannot be used. Okay, and we have verified the parallel tuned circuit, and we have derived the relation for the resonant frequency, that is resonant frequency FR equals to 1 by 2 pi root LC, where Z equals to L by CR. That is the frequency at resonant frequency, the impedance is L by CR. This is the condition. Okay, and we have verified what is the need for tuned amplifiers. The less efficiency for radio frequencies and gain is independent of signal frequency or larger bandwidth. Okay, and we have classified the tuned amplifiers as two categories: small signal tuned amplifiers and large signal tuned amplifiers. Here we have stopped. We will verify what is small signal tuned amplifier. The amplifier amplifies the small signal at radio frequency, and the power involved is small. And these amplifiers are operated under class C operation. Hence, there will be distortion will be very negligible. Okay, small signal lo తీసుకున్నప్పుడు పవర్ డెలివరీ తక్కువగా ఉంటుంది, and secondly it is operated in class A operation. We know for class A operation the distortion is small. And similarly large signal tuned amplifier, they amplify the large signal at radio frequencies. As the power involved is large, these amplifiers are operated class B and class C operation, and the distortion is large. But when we are designing these circuits, the tuned circuits or tank circuits, these harmonic distortions can be eliminated. Whatever the harmonic distortion that is available in class B and class C, that can be avoided by using the tank circuits. Okay, now we are going to the actual topic. We are going to classify the small signal tuned amplifiers that are again classified as single tuned amplifiers and double tuned amplifiers. Okay, we are going to verify what is single tuned amplifier and what is double tuned amplifier. Single tuned amplifier అంటే ఏంటో చెక్ చేసుకుంటాం, అలానే డబుల్ tuned amplifier కూడా చెక్ చేసుకుంటాం. Okay, first one, single tuned amplifier. Single tuned amplifiers, one parallel tuned circuit is used as a load. Now single tuned ki double tuned ki very different statement in the contest. In single tuned amplifier only one parallel tank circuit or tuned circuit used as a load the output lo we will use only one tuned circuit, whereas double tuned amplifier two two inductively coupled tuned circuits are used per stage. Both the tuned circuits being tuned with the same frequency. And on double tune, we are going to use the two tuned circuits per stage, and these two tuned circuits are operated with the same frequency of operation. See the circuit diagram for the single tuned amplifier. Single tuned amplifiers are classified as first one. The circuit you can use any of these circuits. You రెండిట్లో ఏదైనా ఒక circuit తీసుకోవచ్చు. If you verify this circuit, the first circuit you can verify circuit is capacitively coupled. And now output is taken with respect to the coupling capacitor CC. You can verify by using this CC, we are taking the output value. The output capacitance is taken at this point. Similarly, the second one, the transformer coupled or inductively coupled single tuned amplifier. Here, the output is taken with respect to inductor. Okay, these two are the two classifications of single tuned amplifier. As entire circuit we have verified is circuit previously tuned circuit amplifier verify ila output తీసుకోవడం చూపించాం. Now this is the tank circuit. Tank circuit ఎలా తీసుకోవచ్చు. Okay, these two come under the same configuration. It is only the difference is where we are taking the output. Output ఎక్కడ తీసుకుంటామంటే డిపెండ్ అవుతుంది. And by this configuration, the impedance matching problem can be eliminated. Here, there may be chance of impedance matching by using the coupling capacitor model. Okay, exam point of view, they will ask to explain the single tuned amplifier circuit and operation. You can use any of these two circuits. Even of circuit में తీసుకొని చెప్పొచ్చు. రెండింటి కూడా analysis same. You can use any of these two circuits. If you remember the two circuits, you draw the two circuits and start to explain the circuit construction and circuit operation. Circuit construction and circuit operation, one circuit draw chesi explain cheyచ్చు. See, we verify what is circuit arrangement. In the figure A, the output is taken with the help of capacitive coupling, whereas for the figure B, the output is taken with respect to the inductive coupling. And first circuit వచ్చి capacitive coupling ద్వారా తీసుకున్నాను, సెకండ్ సర్క్యూట్ వచ్చి ఇండక్టివ్ కప్లింగ్. చూడండి అవుట్పుట్ ఎక్కడ తీసుకుంటున్నాను అంటే డిపెండ్ అవుతుంది. మళ్ళీ ఒకసారి capacitive coupling అంటే we're taking the output across CC. CC is the coupling capacitor. The output V0 is taken at this point. Whereas for this, the output is taken with a mutual induction from the inductor. That is the output. That is without having any coupling capacitor. The only difference is that the impedance matching problem can be reduced by using inductively coupled amplifier. Okay. The input is applied between the base and emitters. You can verify the input is applied between the base and emitters, and R1, R2, and RE are used to fix the operating point. A circuit lines are on point. What is the purpose of the input resistances? Input resistances to check this base the resistance R1, R2, and similarly RE. The three resistance in the it is used to fix the operating point. The circuit may operate చేయటం అంటే ఆపరేటింగ్ పాయింట్ ని స్టేబుల్ గా ఫిక్స్ చేయడం కోసం యూస్ చేస్తాం. That is, it is used to fix the operating point. Similarly, the capacitance CE is used as a bypass capacitor. If you are using CC, it is used for coupling capacitor. Similarly, the tuned circuit L and C acts as a connector load. If you verify, the tuned circuit is connected across the corrector terminal. Therefore, we can simply call this as corrector. The corrector load connected this tuned circuit. Remember this circuit, we are going to draw the hybrid bimodal for the circuit. Then hybrid bimodal draw cheyali. Ide circuit ni meer gurtu pettukondi. I will show once again also. Okay. The circuit is generally adjusting the screen. See, in the circuit we have the C. C is generally a variable so that the resonant frequency of the circuit may be adjusted. If you verify in the tank circuit, the C is indicated as arrow mark. Arrow mark and it is used for a variable capacitance to adjust the frequency of operation. Okay. C is generally variable so that the resonant frequency of the circuit can be adjusted. The value of capacitance and inductance of the tuned circuits are adjusted in such that it is adjusted such that the resonant frequency is equal to the frequency of the applied signal. అంటే మనకి రెజొనెన్స్ రావడానికి కండిషన్ ఏంటంటే ఎప్పుడైతే ఇన్పుట్ ఫ్రీక్వెన్సీ ఎక్కడ అప్లై చేస్తున్నాం, దిస్ ఈస్ ద సిగ్నల్ వీఆర్ అప్లైయింగ్ విఎస్ వెన్ ఎవర్ దిస్ ఫ్రీక్వెన్సీ ఆఫ్ ఆపరేషన్ అంటే నేను పర్టికులర్ 2 kHz దగ్గర ఆపరేట్ చేస్తున్నాను. If this 2 kHz is equal to the tank circuit frequency, then the circuit will be in the resonance condition. Okay, like this, when the applied frequency is equal to the tank circuit frequency, then the circuit is said to be under resonance. Okay, such that the resonant frequency is equal to the frequency of applied signal. Then at that point, that signal must be amplified. ఎక్కడ amplify అవ్వాలంటే ఎక్కడైతే ఈ రెండు ఫ్రీక్వెన్సీస్ మ్యాచ్ అవుతున్నాయో, రెజొనెన్స్ కండిషన్ ఎక్కడైతే వస్తుందో ఆ పర్టికులర్ ఫ్రీక్వెన్సీని we are going to amplify. Okay, that is called the center frequency of the operation. See, that is the circuit construction and the operation. In circuit operation, the high frequency signal that is to be amplified. And నాకు ఏ సిగ్నల్ అయితే amplify చేయాలనుకుంటున్నాను, that must be applied between the base and collector. Between the base and collector, the value of C is changed such that the resonant frequency becomes equal to the frequency of the signal. And similarly, at resonance, the tuned circuit offers very high impedance to the signal frequency and appears large output across the output and appears large output across its. Okay, and similarly, if the signal contains many frequencies, these frequencies corresponding to the resonant frequency will be amplified and other frequencies will be rejected with the tuned circuit, so that tuned circuit amplifies the desired frequency. Once again repeat చేస్తాను, the whatever the signal that must be applied అంటే మనం ఏ సిగ్నల్ అయితే అప్లై చేస్తున్నామో ఆ సిగ్నల్ ని మీరు అప్లైయింగ్ టు ది సర్క్యూట్. ఇక్కడ నేను డిఫరెంట్ ఫ్రీక్వెన్సీ అనే ఇన్పుట్ ఫ్రీక్వెన్సీ నేను 0 హెర్ట్జ్ నుంచి సమ్ మెగా హెర్ట్జ్ వరకు వేరీ చేసుకుంటూ వెళ్తున్నాను. ఇక్కడ సోర్స్ సిగ్నల్ విఎస్. When we are varying this frequency, when we are varying this VS signal, source signal frequency ni vary చేస్తున్నప్పుడు ఏమవుతుంది, at one particular point of time ఎక్కడ అవుతుంది, when the source signal frequency and tank circuit frequency is matched, then the circuit is set to be under resonance. అంటే సర్క్యూట్ అనేది రెజొనెన్స్ కండిషన్ లోకి వస్తుంది. Then at that particular frequency, that signal will be amplified by the circuit. And the circuit ఏం చేస్తుంది, రెజొనెన్స్ అయ్యేసరికి ప్యూర్లీ రెసిస్టివ్ అయిపోతుంది. Then this tank circuit will amplify that particular frequency. ఎక్కడైతే మనకు applied frequency resonant frequency match అవుతుంది, circuit resonance condition లోకి వస్తుందో, then that particular frequency will be amplified. That is, the signal contains many frequencies, the frequency corresponding to the resonant frequency will be amplified and other frequencies will be rejected by the tuned circuit. Therefore, the tuned circuit amplifies the desired frequency. Next, see, this is the hybrid pi model for the given circuit. So circuit observe change. Everyone observe this circuit. ఈ సర్క్యూట్ మీరు రిమెంబర్ చేసుకుంటూ వెరిఫై చేయండి. యూ హ్యావ్ టు వెరిఫై దిస్ సర్క్యూట్. ఈ సర్క్యూట్ వైట్ పేపర్ మీద డ్రా చేసుకొని try to verify the circuit. Okay, we are taking the single stage RC, that is we are taking the output across the collector either by using inductively coupled or capacitively coupled. For this circuit, this transistor is now being replaced with hybrid pi model. Okay, what are the components verify just R1, R2, RE, C dash inductance L, emitter resistance RE, and bypass capacitance C. Okay, if you observe this circuit, this circuit is replaced by hybrid pi model. In hybrid pi model, we are having this configuration. The transistor is replaced with hybrid pi model, that is C B dash C, C B dash C, GM into VBE, RCE, RB dash RB. These are the hybrid pi model components. Okay, that circuit is replaced with respect to these components, and C dash L and R. Inductive with losses, we are adding L plus R. Okay, Ri is the component. And this above circuit, if you verify, then hybrid pi model, this R dash, RB dash C and CB dash C is a component that is in between the input and output circuit. Therefore, we have to divide this circuit into two parts. The effect of this component on the input side and output side is modified with the help of Miller's theorem. Okay, by using Miller's theorem, the circuit is redrawn. Circuit malli redraw chestam. ఏంటంటే ఒకసారి చెక్ చేసి మీకు ఏదైనా డౌట్ అనిపిస్తే అడగండి. ఎనీవన్ మీకు ఎవరికైనా ఏదైనా డౌట్ అనిపిస్తే అడగండి సర్క్యూట్లో. ఎందుకంటే యూ హ్యావ్ టు డ్రా దిస్ సర్క్యూట్ ఫర్ ద అనాలిసిస్. ఎగ్జామ్ పాయింట్ ఆఫ్ వ్యూలో దే విల్ ఆస్క్ టు ఎక్స్ప్లెయిన్ సింగిల్ స్టేజ్ ట్యూన్డ్ యాంప్లిఫైర్, derive the relations అని అడగరు. మోస్ట్ ప్రాబబ్లీ 14 మార్క్స్ క్వశ్చన్ అడగడానికి ఛాన్స్ లేదు. ఒకవేళ అడిగినా కూడా 7 మార్క్స్ కింద అడుగుతారు. 7 మార్క్స్ కింద అడిగినప్పుడు మన సర్క్యూట్ కన్స్ట్రక్షన్, సర్క్యూట్ ఆపరేషన్ వరకు ఎక్స్ప్లెయిన్ చేసి ఇఫ్ యూ రిమెంబర్ ది సర్క్యూట్ డయాగ్రామ్, దట్ ఈస్ సఫిషియంట్. ఓకే, ఇఫ్ ఇన్ కేస్ దే ఆర్ ఆస్కింగ్ ఫర్ ద డెరివేషన్, వీ హ్యావ్ టు గో ఫర్ ద డెరివేషన్. డెరివేషన్కి వెళ్ళాలి అన్నప్పుడు మాత్రం వాట్ ఆర్ ద స్టెప్స్ యూఆర్ గోయింగ్ టు సీ నౌ, those steps must be remembered. మీరు 1 or 2 times ప్రాక్టీస్ చేస్తే ఈజీగా ఉంటుంది. బట్ టు ప్రాక్టీస్ దట్ ఆల్సో యూ హ్యావ్ టు డ్రా దిస్ సర్క్యూట్. ఈ సర్క్యూట్ ని డ్రా చేయలేకపోతే మాత్రం కష్టం. హైబ్రిడ్ పై మోడల్ and hybrid pi model, by applying the Miller's theorem, we are dividing the effect of this component on input and output. We have modified the output circuit like this, the entire circuit like this. This is the input circuit and this is the output circuit. Okay, we have to calculate the quality factor, we have to calculate the gain across resonance. ఈ parameters మొత్తం కూడా calculate చేయాలి, derivation చేయాలి, and you have to conclude those relations. Or else for derivation అడగకపోతే you have to remember that relations and you have to write that relations. ఓకే, ఈ డెరివేషన్ ఎక్కడైతే నేను హైలైట్ చేశానో ఒక స్క్వేర్ బాక్స్ పెట్టి, You have to remember those relations even though they are not asking for the derivation అడిగినా సరే అడగకపోయినా సరే మీరు రిలేషన్స్ మాత్రం గుర్తుపెట్టుకోవాలి. Okay, see what are the relations? We'll go the derivation. This is the simplified circuit. The impedance at resonance with respect to the quality factor, and similarly impedance under resonance. Okay, what are the values of RP and RL, and voltage gain A and voltage gain at resonance. This relation, you have to remember this relation. Okay, and bandwidth relation. Okay, this is page 1, page 2, page 3, page 4. This is a 4 pages derivation. Okay, the first thing is you have to know how to draw the circuit. ఎలా డ్రా చేయాలని మీరు ఐడెంటిఫై అవ్వాలి. నన్ను ఒకసారి ఎవరికైనా డౌట్ ఉంటే అడగండి నన్ను ఇక్కడ, or else I will start the derivation start చేస్తాను. If you have any doubt, please ask me.